Good morning students. For this emergency situation, we shift our classroom based lectures to these video lectures. So, last week we are discussing the structures, and if you remember that we have already introduced the basic structure, how actually we can represent, how we can use, but quickly we recapitulate before we go to the next portion. Actually, we will be doing further to the structure pointer etc. So, quickly we do the what we discussed last day. So, mainly the structure is a convenient tool for handling a logically related group of data. Like we have given the simple example we have discussed, if it is a student structure, say student name, roll number, marks, CGPA, date of birth, these are number of data that can be related to a student. So, how we can represent a student structure, okay, or say our complex number representation. All of we know this is only two parts, the real and complex, and how we can use that thing. So, these are the one structure example of a structure like tag. So, name is the tag and this is normally we defined as struct tag, and member 1 to member m are the variables, and the variables are the type of int, char or float. Now, normally these member names with a particular structure must be distinct, and member name can be the same as the name of a variable defined outside the structures. We have already discussed this thing, and this struct tag var1, var2, var_n, that means there can be n other structures of type, these are of type tag, what earlier we have defined. This is a student structure, already we have discussed that have the 4 variables, name which is a array, roll number, total marks is of integer type, and date of birth. Now, see struct student A1, A2, A3. So, it is a new data type, student is a new data type, and all these A1, A2, A3 are the student type. Now, similarly, this tag we can define in this way in a compact form, struct tag, and these are the m variables of the structure, and say var1, var2, var_n, these are all of tag type, tag is a structure. These are the other variations we have discussed. I am quickly I am going because we have discussed in details, if you remember. So, this student type and A1, A2, A3 are of all student type of structure, and this is another type where we can omit student, directly we can define the structure and we give the A1, A2, A3, these are the 3 structural names. How we can access the variables of a structure? So, here the variables are name, roll number and DOB. So, I can access A1 dot name, when A1 is the structure, if A2 is the structure, then A2 dot name, A1 dot roll number. So, mainly the structure name dot the variable name, this is the general format. We have seen this example also, complex number, but still again we discuss once more. So, this complex is a structure type, it has 2 parts, real and complex. We define A, B, C. So, these are of complex type. This is the same structure as of complex, that means each A, B, C has 2 parts, real and complex or imaginary, whatever we tell. Now, if we we want to read say 2 complex numbers A and B. So, we have to scan the real part as well as the imaginary part. So, A dot real and A dot complex. Similarly, we scan F, B dot real and B dot complex, both are of type the float real numbers. Now, C is again we have already declared C as the complex structure. So, C dot real is A dot real plus B dot real, that means the real part of A and B are added. Similarly, C dot complex is A dot complex plus B dot complex. So, the imaginary part of A and B are added. Now, as usual we print f %f plus %f. See, one j we have given. So, that when it will print like the c dot real plus c dot complex j, that means a plus b j in this format. We discussed this thing. I already mentioned that unlike the array, that we can actually assign, the full structure can be assigned. If A 1 A 2 both are of similar type of structure, then A 1 equal to A 2, this assignment is valid. Similarly, if A 1 A 2 are similar type of structure, then we can compare also if A 1 equal to A 2. If you remember correctly, that for array it is not possible. Okay. So, we can also do that array of structures, because if we remember that A 1, A 2, A 3, A 4, in this way if I have 50 variables, I want to use that 50, all 50 can be the student type structure. So, what we can do, if since they are all same, so I can just here we write class 50, this is class is an array of size 50. So, directly we can define struct student class 50. When we will access, we will give say class I dot name, this is the general form of accessing one variable of a structure. So, if class 5 is my structure, then class 5 dot roll number, that means this is the roll number of this particular structure class 5. So, this is the array of structures that similarly we can give. So, arrays within a structure, that already we have seen. This is a within this structure, say name and date of birth and marks, these are of array type. So, the array element within the structure can be accessed A 1 dot marks 2. See, just A 1 dot marks 2, A 1 is a variable, structure variable. So, this structure and then the variable name is the marks 5 like marks 2, that also we can access A 1 dot marks 2 in this way. But here it is different, because this is class 5 is the student type of structure and roll number is a variable or it is a member integer member of under class 5. So, these two are different. Now, type def also we have read, but since I mentioned that day that it is very important, since we want to define a new type definition like integer, float, char, already you know that C provides these things. Now, that user can define its own structure or own data type. So, that we can do this new data type we can define using this structure. See, the type def, then we have to give the format type def struct, then similarly the way we have defined member variable 1, member variable 2, member variable n, and we give the name tag. So, now here the tag is a new data type, and that what type of data it is, that it is a structure having this n number of variables. So, tag is the name of the new data type. Now, similarly that we define a complex data type. So, type def struct, since it has two values, real part and imaginary part. So, float real, float imaginary, and we give the name the complex. So, this is a complex, it is a new data type. Now, I can define now like int, like we write int ABC or float ABC. Now, we can do complex ABC, that means ABC all are that 3 variables of type complex. Similarly, array of structures just now we read. So, complex array 100, that means this is a array of structures and each element of this array of type complex. Now, the similar way we can initialize our new data type. So, this complex, say A and B we have defined as the, we have declared A and B as the complex data type. It has two parts. So, first one is real part, second one is the imaginary part. That means, A is 1.0 plus 2.0 j, B is minus 3.0 plus 4.0 j. That means, A plus I j or A plus B I or A plus B j form. So, it is written like that, A dot real is 1.0, B dot real is minus 3.0, and similarly the imaginary part is. Now, if we want to swap the two variables A and B, both are of same type, complex type. So, complex we just call the function that this is a swap function, it has two arguments, complex A and complex B. Here complex is, if we remember that it is of type, a data type like int. Now, complex temp. So, one TMP variable we have defined, we declared that TMP is of type complex. So, for swapping we need a temporary variables, only difference is here that under this temporary thing TMP there are two members, one is real part or one is the imaginary part. So, temp equal to A, since already we have read that the assignment is possible for structure. So, these are two structures. So, temp equal to A, similarly A equal to B and B equal to temp. So, here unlike the array we can, those it has two parts real and imaginary, but directly we can assign the structures, structure values will be assigned. So, it is possible. Now, if we write the main program, first this is the struct float real, float imaginary, complex, already we have signed, this is my definition of complex type of structure. I write the swap function, it has two arguments, the two complex numbers A and B, and just now we read that temp is a complex type we declare, and we have written that the swapping A is shifted to temp, B is shifted to A, then temp is shifted to B. So, that A B can be swapped. Now, we can print complex in this way, because print is a function to print the any complex number and complex A is the argument, then we have it has two parts. So, we printf %f A dot real and A dot imaginary, normally the way we print. Now, in the main program we first define two complex numbers, complex x equal to 4.0, 5.0, that means x dot real equal to 4.0, x dot imaginary is 5.0. Similarly, y dot real is 10.0, y dot imaginary is 15.0. Now, print x, print y, that means this value, the original value of or initial value of the two complex numbers x y will be printed. Now, we call swap function. So, swap x y. So, already we have seen that swap is it is swapping the A and B using one temporary variable which is of type complex. So, print x, print y. Now, it should be if the way we have done that print x and print y, if we give that it should be swapped, that means it will print x will give the original y value and x. See what it gives? See, it is the output, that means original values were x is 4 is the real part, 5 is the imaginary part, for y it is 10 is the real part, 15 is the imaginary part. Again after swapping also we see the same, because that means it has not swapped. Why? Why it is not swapped? So, see the what is written, no swapping takes place, since only values are passed to the function, the original variables in the calling functions remain unchanged. If you remember when using the normal variable we have done, then actually values are copied. That means, here also when we are calling the function that says swap x y and swap is here, swap function is here. So, actually the real part and the imaginary part are just copied. So, only the values are passed. So, that is why from the calling program, from the main program, when that we give a print x print y, that it is not getting the swapped value. It is actually the same initial value before calling the program, what was the x y, that value is there. That means, changed values are not returning from the function. If you remember, this is the same thing what earlier we have done, that simply the swap function, when we swap, we have read for swapping two variables without using pointer. Okay. So, now we have to return the structures. That means, how we can get the updated or changed value from the function. So, returning structures. So, it is also possible to return structure values from a function. The return type of function should be the same as the data type of the structure itself. This is the same, if you remember that the return variable what we have done, it is of the same type as that of the function data type. Here also it is same. The return data type of the function should be the same as the data type. Only thing is here the argument of the functions are a user defined data type, not the what the C provides like integer, float or character. So, this is the only difference. Otherwise, the C provision is same, that the returning what the structure will return, that is the same data type as this thing. So, it is the complex. So, since we are returning temp, so temp must be of type complex. Since add the function, the type is complex. So, the add function is returning temp. So, temp must be of the same data type, and here it is complex. So, direct arithmetic operations are not possible with structure variables, because we have to we see that how we can do the addition. So, first is here the similar way we have, this is addition of two complex numbers. So, we first define or we define a structure of new type definition, new data type is the complex, because we want to add complex numbers, and float real and float imaginary, these are the two members. Now, we write the add functions. As already we have mentioned that add means it must return the sum, and sum, again sum has two parts, the real and imaginary, because the sum of two complex numbers is a complex number. So, the data type of the add function must be of complex. So, complex add, and then two arguments are complex A, complex B. Now, as usual we declare another temp variable of type data type complex. That means, it is again a structure having two member real and imaginary, and real and imaginary are of float type. Now, temp dot real, tmp dot real, because it is a complex type. So, it has two parts, temp dot real is a dot real plus b dot real, because when a is passed as an argument, that means the real part as well as the imaginary part that has passed. So, I just add the real part of a and b. Similarly, temp dot imaginary is the imaginary part of a dot image and b dot image, that will be added. So, now temp is a complex, it has two parts, we got real and imaginary. So, return TMP. Return. Now, we return thus. So, TMP is a structure and we return this TMP in this way. Now, if we write the main function, that first we declare num1, num2, sum as the complex data type, user defined data type. We have defined the structure typedef struct complex. We read num1 and num2 because we have to add two complex numbers. So, we scanf ampersand num1 dot real ampersand num2 dot image, because see we have given ampersand, it is same because these are of floating point real numbers or floating point numbers. So, I give the same way we read, we scanf we give, and scanf the num2 dot real and num2 dot image, both are of floating point types. So, now I have available in my hand or in the main program is available is num1 dot real, num1 dot imaginary, num2 dot real and num2 dot imaginary. Now, I can add because I have declared sum as also complex type. So, sum dot real and sum dot imaginary, it has two variables. So, sum equal to add num1 num2. If we see the function add function, that return temp, because what is temp? Temp is temp dot real and temp dot imaginary, the two variables, and the value, what are the variables? The value of the variables, the temp dot real is the sum of real parts, temp dot imaginary is the sum of the imaginary parts of AB. So, now sum equal to add num1, that means it will be returned. So, when I call this add function with the arguments as num1 and num2, which are of data type complex. So, they will return the two values, that real temp dot real and temp dot imaginary. So, now I print that sum is C %f plus j %f sum dot real sum dot imaginary. So, since now we temp is returned. So, sum dot real and sum dot imaginary are available. So, it will be printed. So, the structure is returned the similar way. Now, we take another very simple example. Say, okay, one thing I tell. So, up to the last example already we have covered in the last class, but again we have recapitulated this part, because today again we will continue the more of structures, particularly the structure pointers, etc. So, we recapitulate the previous things also. Now, we see some simple examples using this new data type, and mainly the using structures, how we can declare, how we can define new data type and how we can use in our C program. The simple example is compute perimeter of a polygon. Now, see the program. So, like hash include stdio.h, we know that library function we include. Then we have to define a polygon. Now, see that we do not have any in C, we do not have any polygon type of data type. So, I define this is a user defined data type. So, we use typedef struct int size float length 10 polygon. That means, it has again two member variables. Variable members are, one is size of type integer and one is length, say this is a array. That means, my polygon can have 10 lengths, because float, this is float length 10. Okay. Then what is sides? Sides is number of sides in the polygon. This sides is actually number of sides in the polygon, and then the length of each side, and here we have defined length 10, that means maximum 10 number of sides can be we can consider here. So, that length is given, that means length 0 to length 9, that there are 10 lengths we can define. Now, we define a function, say perimeter, because we want to compute the perimeter, actually compute perimeter this is. So, float perimeter argument is polygon P, because I want to compute the perimeter of a polygon. So, I declare my variables. So, float peri is 0.0. Okay. This is a floating point numbers. So, peri is 0.0. Int I is one integer. What I do? So, these are simple our C data type int and float, and these are the normal variables, the one real variables peri floating point type, float type, and this is of integer type I. Now, for I equal to 0, I less than p dot sides I plus plus. So, what is p dot sides? Because p is a polygon type, p is a polygon type. So, it has two parts, p dot sides and p dot length 10, say length I. So, p dot sides is actually gives the number of sides in this p, what is passed in the argument. So, number of sides. So, that means for I equal to 0, I less than p dot sides I plus plus, that means for all sides I am considering one by one all the sides is what we are doing, then peri is equal to the p plus peri plus p dot length I. So, what we are doing, because p dot sides will give the number of sides. So, when I equal to 0, say the length 0, I equal to 0, this is length 0, and initially it was initialized peri equal to 0. So, peri equal to peri plus, that means 0 plus the length of the first sides. Then I equal to 1, then it is added the first sides, length of first sides plus length of second sides. Similarly, length of third side, fourth side, all the sides up to that, all the sides that it has written that sides here, it is passed here polygon P and it is added. Okay. So, now return peri. So, here actually I am computing all the sums of the lengths of all the sides, and the how many sides are there, that we are actually reading in the variable int sides, and this length will be giving the lengths of each side, that length 0, length 1, length 2, like that, and that we have passed, and we in a loop we are just computing this thing, and then we are returning. Return peri means that we are returning the perimeter that we have computed here. Now, we write the main program. So, here what we have done? Here one structure we have defined, a polygon type structure. It has two variables, one is the sides, actually sides means number of sides in the polygon, and the another is length array, because number of that many sides, that each one has the length, because if it is a 10 sides polygon, 10 sides the polygon has, then there will be 10 different length of each side, and we have added this in a function. So, in the main program, first we define or we declare a variable called shape of data type polygon, because already we have defined polygon here. That means, when we define polygon shape or declare, that means it immediately I know it has two variables, one is shape dot sides, one is shape dot length I. One is shape dot sides, one is shape dot length I I can be from 0 to 9 10 values. Now, int k one variable we declare as of integer type, float peri is another variable of real numbers, floating point numbers, floating point variables. Now, I read, because I have to read the shape dot size and the lengths of that thing. Now, see, first I scanf %d ampersand shape dot size, because number of sides, that is the integer. So, number of sides, shape dot sides is actually the number of sides in the polygon shape. Now, once I know the number of sides, then what I do? Say for k equal to 0, k less than shape dot sides k plus plus. That means the since I know the shape dot sides is the number of sides. Now, for each side I have to read the length of each side. See, here I am doing this thing as a normal array. See, here your polygon is a new data type, and it has two member variables. One is integer type, another is float type, that is a array. That means, this is a array of floating point numbers. What it represents? This array of floating point numbers, it contains the values of the length of each side. So, length is the array contains the length of each side. So, that we have to read in a loop, because we know that array, whenever the array elements we have to read that in a loop, we have to read the thing. So, for k equal to 0, k less than shape dot size k plus plus scanf %f that ampersand shape dot length k. So, see, this is shape dot length k, that means shape is my structure, that polygon type structure, and length is the another variable which is actually array. So, this length k, because each element of the array, that we are in a loop, we are reading all the length of the sides. How many lengths will be there? Because the number of sides. So, that is why number of sides is the shape dot sides. This is my loop index. Okay. This is my k is the loop index, and these are my loop variables, the shape dot sides. So, now these all lengths are read, number of sides are all read. Now, we have to compute the perimeter. Now, we call the function, because I have written a small function. What was the argument? Argument is the polygon p. That means, here peri equal to perimeter shape. Shape is my polygon, and whenever I am calling the function perimeter, that perimeter has the argument shape, which is a polygon type, is a polygon p. So, immediately the value passed are shape dot sides and one array, that which is the shape dot length k equal to 0 to 9. So, that is it is passed, okay. K equal to 0 to that shape dot sides minus 1. So, that is going here. So, now here it is passed. So, here now this function will be executed, and this function will compute the perimeter of the polygon shape, and it will return the perimeter. So, after returning this printf, perimeter is the %f peri, because here perimeter function is of data type float, because it will return a variable of type float, because I computed the perimeter, which is a floating point number. Then it is returned, perimeter is returned. Okay. Now, how we can estimate the size of a structure? If you remember that we know that C provides the integer type, float type and character type, and the depending on the compiler, that what will be the how many bytes the integer, one integer variable will require or one floating point number will be required, that floating point float type variables, real numbers, float type variables will require, that is already defined. Now, see, one structure has more than one variables of type integer, character or float. So, last day we have I mentioned that structure should be the sum of this bytes for each variable it is required, each variable member. Now, we see actually the size of a structure is computed in slightly different way. Okay. It again this I should tell again it has a different type of structure when we consider that how many bytes it will be required for a structure. So, size of is size of for a struct variable. Struct variable means the structure variable, the user type user defined new data type, that what will be the. So, if it is a user defined new data type, what will be the size of that thing, because it is a variable. Somewhere we see that some structure has one integer, one floating point, somewhere it is two integers, one array of type float. So, then what will be the structure or a size of the structure, how actually it is determined, how it is computed. So, see, it is written that size of struct variable is not always equal to the sum of the size of each individual member. It is not straight away that if it has one integer, one float type, that means we know integer is 4 bytes and say float is say 4 bytes, then it is 8 bytes, no, okay, it is 8 bytes. Now, if say one integer and one double type, we know the for integer it takes 4 bytes and for double it takes 8 bytes, then we will see instead of 12 bytes it may be 16 bytes or it may be different. First we see that how actually it will be computed. So, not always it is, summary is that not always it is directly the sum of the bytes required for two member variables. So, padding is added by the compiler to avoid alignment issues, because the two, whenever we declare a variable, that we actually reserve space in a memory repeatedly. From the first day only I am repeatedly telling this thing. So, it will reserve say for integer a 4 bytes, and for a double type, if it in the structure one variable is defined as a double, for that it will be taking as a 8 byte. So, for symmetry, that it will be these 4 bytes will be added another 4 bytes to make a or to avoid some alignment problem, because both should be aligned. Giving again. So, this is called the padding. Padding is only added when a structure member is followed by a member with a larger size or at the end of the structure. Second point is very important, because it actually tells the ordering of declaration. That means, if my second one, padding is only added when a structure member is followed by a member with a larger size. That means, if the second member requires more bytes, so that it is a larger bytes, larger in size, then only the padding is done, otherwise not. We will see that thing. So, exact convention may vary from one compiler to another, because already we learned that how many bytes for each variable it is required, that is also varied from compiler to compiler. Again this padding structure also varied from compiler to compiler. We see one example. See, we take one simple example, that say it is a main program, and this main program, under this main program one struct A, one structure we have, just we declare that once it is of structure. Within this structure, say there are 3 member variables, one is x, z and y, and it is declared in this way. We know that int x, and int is size of int is 4 bytes, 4 means 4 bytes, unit is bytes. Then next is double z, we know that size of z is 8 bytes, and then is short int y. So, we know that if it is declared as a short integer, the size should be 2 bytes. That means, x is of 4 bytes, z is of 8 bytes, y is of 2 bytes, and see the declaration of the ordering. Okay. See here x int is followed by z double, which is larger in size than x, and hence padding is required, because see the last slide, padding is only added when a structure member is followed by a member with a larger size. So, here z has larger size, z is declared as double, z needs 8 bytes to define. So, hence padding is required after x. Okay. So, see, so first x is declared. So, see the picture, the x is of 4 bytes, and next z is 8 bytes. So, we will not start z from here, rather we will pad another 4 bytes, that means we will pad the differences between z, the size of z and x. Since it is 4 bytes, z is 8 bytes. So, 8 bytes minus 4 bytes, that means this red color, this is my padding size is of 4 bytes. Now, this x with padding becomes the 8 bytes. Now, after that z is stored as 8 bytes. So, there will be no alignment problem, that means x and z. Next is short int y, and it is 2 bytes. So, also padding is required at the end for data alignment. So, here it is say 2 bytes. Now, we will tell, now since there are no more variable declared, so I cannot stop here, because so that means it is the largest bytes required for some variable. So, 8 it is z is 8 bytes. So, here after 2 again this red color is the padding, this should be the 6 bytes, because this should be the 6 bytes, because this is 8 minus 2. So, these 6 bytes are there. So, this is my, so now what will be the size of this structure? Size of this structure will be 24. It is not, if it is only, this should be the 4 plus 8 plus 2, not 14. Normally, if we just add the size of 3 variables, because it is one integer, one double and one short int. So, for normal cases other than structures, if it is simple variables, not the structure variable member of a structure, it should be 4 plus 8 plus 2, that means simply 14 bytes. But if it is a structure, then actually it will be, it is 24, because the largest bytes. So, first it will be added, so that there will be no alignment problem. That means, when it will be reading, remember when it will be read like a dot x, a dot z, a dot y. So, that actually it will every time it will start from here, a dot x, a dot z, a dot y like that. So, it is padded like that. So, here it is this is the how the actually in the memory the variable members are stored and there how the they reserve the memory space and what will be the size of structure, that means how many bytes are required for this thing. Now, we can printf size of struct is size of struct A because the structure A, and we can size of struct is 24, it will give you the 24, this is the thing. Now, another example we see. So, again one struct B and see here just first one is the double z, again that 3 variable member, 3 member variable z x y, but the ordering of declaration is different. So, first thing we define double z, then int x, it is of 8 bytes, int x 4 bytes and then 2 bytes. Now, we see the members of the structure are sorted in decreasing order of their size, hence padding is required only at the end. So, that means here it is 8 bytes z. Now, it will start because that is the largest, we see the next one is 4 bytes. So, it will start from here 4, and since it is of 2 bytes the short int. So, still the memory space is there. So, it will be stored next to y 2 bytes, and then because it is 4 plus 2 6. So, another because there are no more member variables. So, these will be a padding. So, this will be a 8 minus 4 plus 2, that is 2 bytes. So, now this size of this thing is 8 plus 8 means 16. So, if I give the size of struct is 16. See the same 3 member variables, only the ordering of declaration is different and it is giving the different size of the structure. Earlier it was 24, for the same x, z and y. Again this is z x y, that means the same 3 member variables, same type, z is double, x is int, y is short int, but the size of structures are different because it is padding. And again this is actually different from it may vary from compiler to compiler, that already we have mentioned. So, with the thing same example, with that same example of 3 variables, that double 3 member variables z, and now this is z, y, x. So, z is 8 bytes. So, first 8 bytes it will take, then y is short int. So, it is of 2 bytes, and see that size of int is 4. So, see here it is padded 2 bytes and then it is 4 bytes are, this is also another option, but here also it is 16, the 4 bytes are here, it is given. So, followed by x, and hence padding is required after y, because y is short. Again the second point you remember that if it is a the next one is the larger bytes, then it is padded. So, that rule is followed here. We may start x from here, then also padding can be here, but the rule of padding is that if one member variable of smaller size, that means the bytes are followed by the larger bytes, then it is padded. So, that is why padding will be here, not at the end, but it is the full, the size of structure is same, it is 16. Okay. Now, these are some exercise problems, that is an example we can do this thing, that extend the complex number program to include functions for addition, subtraction, multiplication, division. For complex number we have only done for addition. So, now since we know we know the how to do subtraction, multiplication and division of complex numbers. So, you can extend, you must do this program, some practice problem. Then define structure for representing point in 2-dimensional Cartesian coordinate systems, and you write these functions to compute the distance between two given points. All of we know that root over x 1 minus x 2 whole square plus y 1 minus y 2 whole square. So, a point is actually x 1 y 1 and x 2 y 2. So, that one you define one structure and do this computation. Write a function to compute the middle point of the line segment. The coordinate geometry, you know the formula, just do that thing. Write a function to compute the area of a triangle. All of we know the formula for how to compute the area of a triangle when the coordinates of the 3 variables are given. That means, one, you have to define the structure of a point. Then define a structure to represent students' information, name, roll number, CGPA, read the data corresponding to n students in a structure array, and find out the students with the highest and lowest CGPA value. I think this example 3 already we have done in the lab class. For section 3 already we have done. Section 4 students, you must do this practice problem. Okay. So, the structure definition, how it is stored, how we can access the member variables, how the most important thing is that how we can define a new data type or user defined data type, that depending on like a point, a complex number, how we can define this data type that we have read, that it is using structure, how we can define, and then how we can access the values and how we can play with these values. That means, we can, when we will be computing something or some operation we want to do, how to do these things. Okay. So, the basic concept of introduction and how we use in a C program, that part we have done.